Okay. Okay. Are we back? I think we're back. Though I'm not sure. I wonder if you can properly hear that, to be honest. I should increase that just a little bit. And I really want to increase the. I want to add a filter to this. My mic audio probably isn't quite right. Testing, testing, testing. 1, 2, 3. Testing. Ha! Hiya! 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 Okay, that works. There we go. That should sound a little better. Alright, now we should be good. Sorry about that. I had a little bit of a whoopsie daisy. Ruh-roh. This cord took a lot longer than I wanted it to turn on. Oh. Okay. Huh. Hopefully everything won't explode again. There we go. Now we got that pinned back. Let's see if we can actually figure this out now. Oh, by the way, the problem that I had was that pipe wire decided to explodiate itself. Don't know why, just did. I think the reason why is probably because I was using an equalizer. I'm no longer using the equalizer. So, who knows. Anyway, let's see if we can figure this out. Alright, so the input. First line of the input contains an integer n. One, so the n can be a number. Hello, Eterna. N can be a number between 1 and what looks like 100,000, or 10 to the 5th power. The size of an array A. Okay. So the second line contains indistinct space-separated integers A1, A2, AN. That can be. So there can be. Wait. So each. Okay. So each number in the array can be 1 to. I don't know that off the top of my head. I think. Is that like a billion? I think possibly. Hold on. Calculator. 10 to the 9th power. It's like million. Yeah, I think that's a billion. Yeah. Okay. By reversing exactly one segment of A. I'm still not sure what it means by reversing one segment. Like, what's the maximum? Like, I don't. Alright, let's look at this. So, let's look at our examples. Let's see if our examples will shed some light. So, oh wait, our output should be yes or no without quotes depending on the answer. If your answer is yes, then also print two space-separate integers denoting the start and end. Start must not be greater than end. Indices of the segment to be reversed. If there are multiple ways of selecting. Okay, this tells us a lot actually. So, in this case it's yes, and then we're reversing 1 and 3. So, okay, alright. This shouldn't be too hard. It seems like we just have to sort the list and then just reverse a bunch of segments and see if that fits. I'm still not entirely sure, but see, the problem that I have with this is technically. So segments 1 to 3. Oh. This could be difficult. Alright, so 1 to 2. Okay, so it swaps these basically. Alright, I'm starting to understand this. So it's greatest to least. That's what we're looking for. Okay. For those of you that don't understand what's happening here, just imagine that... Man, I don't know how to explain this actually at all, but I understand what it's saying. Let me see if I can try and make sense of this. So let's say we have an array, and let's say our array is like, I don't know, 1, 2, 3, 4, 5, 6. But instead of 1, 2, 3, 4, 5, 6, let's say 2, 3, 4 is actually 4, 3, 2. Yeah, 4, 3, 2. Okay. So in this case, it's not sorted. Oh wait, shit. I just realized I did this wrong. Fuck. Alright, wait. 6, 5, 2, 3, 4, 1. Yeah. In this case, it's not sorted. However, if we take this section right here, whoops, this section right here that I just highlighted, we take that, and then we take, and so let me see if I can make sense of this at all. So we take this number, I'm just going to use a V. So we take this number and we move it to the right, and then the next number we pivot around this number, right? And then we take this number and put it to the left. Okay, so 4 is going to where 2 is right now, basically. And if we do that, then we should, in theory, have... Whoops, I didn't mean to do that. 4, 3, 2, 1. So now we have 6, 5, 4, 3, 2, 1, and now that's sorted, basically. So the easiest way that we could probably... this could be difficult because there's a lot of different ways that this could be. So the problem that we have, right, is it doesn't have to be a 3 segment. Like, the segment could theoretically be whatever size it looks like. Let me see. Entire array to get. So yeah, so there's no limit. The limit is the size of the array. In other words, let's say for example we have 1, 2, 3, 4, 5, 6. So this is not sorted from greatest to least. However, it is sorted from least to greatest. Does that make sense? So if we just take this and then let's do our same thing. Let me make sense of this for you. So we'll do this right here. So that's what we're going to reverse. Okay, and we're not pivoting on 3 or 4. We're not really pivoting at all, actually. What we're really doing is we're really just how do I explain that? We're reversing its order. It's really simple. We're taking this and we're placing 6 with 1, 2 with 5, and 3 with 4. Okay, that's what we're doing. Alright, and so we end up with 6, 5, 4, 3, 2, 1. You see? And it could be any combination. So the problem that we're going to have, of course, is it doesn't have to be this either. It could also be, let's say 1, 2. What would that be? 4, 3, 2. No, wait. 1, 2. 6, 5, 4, 3, right? No, that's not right. That's not what I was thinking. 1, 2, 3, 4, 6, 5. No, it's not quite right either. This is what I want. 6, 5, right there. Okay, so we can have this scenario right here, where you see what's going on here. So this is sorted least to greatest, and then this is sorted greatest to least. We need it to sort greatest to least. So in this case, we would take this section, and same deal, we would reverse it. And there we go. Now it's sorted greatest to least again. So remember that we can only reverse these. Notice that we're going 4, 3, 2, 1, 4, 3, 2, 1. You see what we're doing? 4, 3, 2, 1, 4, 3, 2, 1. That's all we're doing, basically. Now, basically the challenge is, what we cannot do is we cannot just move things arbitrarily. So for example, a great example I accidentally already did was 6, 5. So in this case, you might say, well, what happens if we just flip this? Well, this won't be sorted. If we flip this, then what will end up happening is it'll be 4, 3, 2, 1. However, that's 4, 3, 2, 1, 6, 5. That is not sorted, because 6, 5 should be over here on the right. So that's the challenge. If it's this, then we print no. If it's this, we print yes, and then we give us the indices. However, programming this could be somewhat difficult, because we don't know, in all these scenarios here, we don't know which scenario it might be. It could be any combination of these, any scenario. And the worst part is, there's 10,000. No, sorry, not 10,000. There's 100,000 possible numbers, which means if we do some quick math on our calculator, we can actually tell how big that's going to be. Give me a second. So to determine how much, if we were to brute force this, basically, which is a really dumb way of doing it, but if we were to brute force this, basically, since our maximum possible amount of numbers in our array is 100,000, our brute forcing would be something like, let me think. So I think it would be 100,000 to a power of, you need at least two numbers, so 999,999. Yeah, I think I'm doing that right. What? Overflow. The result couldn't be calculated. Do you know what that means? It's a really big fucking number. We would be sitting here literally all night waiting for our program to finish if we tried to brute force this. So there's got to be a trick to figure out how we can do this the fastest possible way. So let me think about this for a second. Oh, okay. All right, I got it. So what we need to do is we need to basically do two things. So thing number one that we need to do, let's just let's pick one of these examples. Let's pick this example, I guess. We'll pick this example. So let's say this is what we're given. So our input would actually be, not this to be clear, our input would actually look more like this. And that's 1, 2, 3, 4, 5, 6, so that's 6. So this is what our input would actually look like in practice. So let's say this is our example. We know already that we want what would be, in programming terms, it's actually supposed to be the second index, but we're going to call it the third because that's what the program or the people want. So we're going to say third. We know it's 3 to 4, and our answer is no, not 4. 3 to 6, and our answer is yes. That's what we know the output to this example would be. See, so yes, and then 3 to 6, because there's 6 things. So we know that, but our program doesn't know that yet. So we got to come up with a concept here. I don't know why I'm trying to teach this, but I guess maybe it's easier to learn something if you're teaching it. So we need a program that will somehow reliably do this. I think I already know a good way. So I think we should go down the array. So we're going to go down the array until the next number we check is greater than the number we just were on. So what do I mean by this? Basically, I'm going to write a program, or this is the start of my idea anyway, that will check 6 and put that into variable, I don't know, let's say x. And it will check 5. And it will see if 5 is less than x. If 5 is less than x, then 5 will now become the x variable. And then it will check this one. If 1 is less than x, yeah. So if 1 is less than x, sorry, I had to process that for a minute. Then we'll make 1x. So this is fine. This is where we want to stop it, but you'll see what I'll do in a second. So then we're going to check 2. Is 2 less than x? Well, x is 1 right now, so no. 2 is not x. So what we're actually going to do is we're going to keep the 2 last variables. So in this case, we'll actually have kept, let's say, we'll just call this y. So 5 is in y, 1 is in x now. Does that make sense? And we're going to say, okay, so 2 is less than x. You get what I'm saying? So now that we know 2 is less than x, we're going to actually go back 2 times to y. Y is our position that we want to be at right here. Because we know that at this point right here is when our segment should start, in theory. There should be no ifs, ands, or buts about it. Oh shit, I just realized I totally skipped a step. My bad, y'all. Hold on a minute. I totally skipped a step in my entire thinking process, and now everybody's confused. They don't know what the fuck I'm about to do. Hold on. So the first thing we're going to actually do with this is we're going to make, this is going to be called array A. And I'm just going to put that, actually let's, just for illustration purposes, we're going to put it in that actually. Give me a second, let me reorganize myself. So we're going to call this array A. forget that. Well, actually don't forget it. And then we're going to call this array B, just for simplicity. Hold on a minute. We'll call this array B. Now, what we actually want to do, we want to sort array B automatically. So we're going to take, let me write this out for you. Actually, hold on. Create a pre-sorted array for testing. So basically what I'm about to do here is I'm going to take the input that we got and I'm just going to pre-sort it. So we have an idea what it needs to look like out of the gate. So we have something to test against, basically. So we're going to say 6, 5, 4, 3, 2, 1. So that's going to be our sorted array. It's a pre-sorted array. This is not our answer. This is what this array should end up being. This is what we want it to look like. If it doesn't look like this when we do it, then we know the answer is wrong. Or no, sorry. Yeah, we know the answer is no. Anyway, going back, I know I just jumped around. I'm sorry I confused you. But quick recap, we're going to have two variables here. And just to prevent confusion, actually, I'm going to quickly... Oh, I just realized, actually, that it's all fucked up. Hold on a minute. My bad, y'all. I know, I'm a horrible streamer. Anyway. So, what we're doing now, that we... Oh, you're going to sleep, Etherna? Aw, good night, Etherna. Sleep well. It's 2 a.m. Sleep is for the weak. 2 a.m. is not late enough. Anyway, good night. Sleep well. So, basically what I was saying was, after we have our pre-sorted array that we can check against, we now know that we want to find where we need to start swapping at. Okay? And like I said, that's pretty simple. We just have two variables. So, matter of fact, let me actually put this up here. For simplicity's sake. So we're going to have two variables. We're going to start these variables here. We're going to start the variable, we're going to say y is 6, 5 is x, and then we're going to check 1 against 5. And if 1 is less than 5, then we continue. Now we put y as 5 and x is 1. And if 2 is less than 1, then we continue. However, 2 is not less than 1, so we don't continue. And we use y as our... I just realized we don't need two variables, actually. My bad. We only need one variable, because we could just check 1 and 2. And if they're not correct, then we just... Yeah. There we go. We have our variable. So... we know that at position 2, this is position 2, by the way. You can always know because, well, it's really position 1. But anyway, position 2 is where our section starts. We know this because 1 or 2 is greater than 1, which it should not be in an assorted array. Now we have to find the end of our segment, which shouldn't be too hard, actually. So give me a second. So what we're going to do instead is go down the array until one of two things happen. Either we get to the end of the array, and then we know to stop. which in this case we'll be getting to the end of the array, and we'll be stopping. Or hold on a minute. I want to change my example up. I'm sorry. It's a stupid example, okay? I apologize. Give me a second here. I want to make it simple though. Because I just realized this will not account for all scenarios. I can see my viewership dropping rapidly. Anyway. Give me a second. There's a reason I'm doing this. Trust me, there's a reason I'm doing this. Don't get mad at me yet. Wait, something's wrong. Hold on, I screwed something up. No, this isn't the input that I want. This is. Ah, okay. Okay, okay. Here we go. Alright. No, wait. That's still not right. Can it be in the center of it? Wait, can this segment be in the center of it without it fucking everything up? Surely it can, right? Oh, I see. I don't have enough numbers for that to make sense, I bet. Oh, no, I do. I'm just an idiot. Listen, guys, hear me out. Just bear with me for a second. Just bear with me for a second. I know it's dumb. Just bear with me for a second here, okay? I didn't actually need more numbers, but whatever. So we're gonna have 7 now. Okay. Oh wait, I need to move this too. Alright. Okay. Yeah. That'll work. Okay. It's gonna make sense, just trust me. So, now what we need to know is the end of our segment, okay? So in order to get that, we need to either reach the end of our array, or we need to compare these two right here and get the one in front of it. So in other words, wait a minute, I just realized something. It's all fucked up. I'm getting the variable wrong. 2 is actually going to be our variable because, yeah, because of the way the challenge is. Anyway, And in this case, we're going to do the same thing. We're going to do the same thing. It's really that simple. We're going to do the same exact thing. We're just going to compare the other way around. So we're comparing if 6 is greater than 1, which it is, then we know that this right here, this is the end of our thing. So that's going to be our variable y. So this is going to be our variable y. So we have x and y. You see how this is working now? So we're comparing, to get our first section, we're comparing 2 to 3. And then to get our last section, we're comparing 6 to 1. And this will tell us that this is the end of our section. This will guaranteed work every time because it has to be true that this is the case. Otherwise, we're just going to get we're going to get a no anyway. If this wasn't the case, then we couldn't sort it, in other words. Is the number we had. Okay. All right. I'm starting to see the program in my head right now. How long have we been at this? 37 minutes? That's not too bad at all. I feel like I can program this relatively fast. All right. Let's see here. Is that everything? Kind of, but not really. How are we going to swap them? That's the real question. Should be pretty simple. We'll just put in another array and just go over it backwards. Should be quite easy, in fact. In fact, it might actually be even easier to... Let's call this array... I'm going to call this our check array. And then we're going to make another array from this array. We're going to call this array B instead. 2, 3. Well, no. We want this to be 6, 5, 4, 3, 2, 1. No, 2. Okay. So now we have this array. We're going to make this B array by going backwards over this. We're going to go, all right, the first part of our array is 6. Okay. The next part of our array is 5, okay? The next part of our array is 4, okay? Next part of our array is 3. Last part of our array, 2. You get it? We can go backwards or forwards over arrays in programming. Not to worry. Quite easy to do both. Okay. Right then. Once we have that, hold on a minute. Actually, we don't need to do that. Yeah, we don't need to do that. We can swap this directly. We could just swap it in the A array. Yep. It's easier to do that. And less complicated. Oh, what the fuck am I doing? 4, 3, 2. And then we check for equivalency. And if this is true, then not to worry, we still have our x and y variables. So we're going to say, we're going to get a little bit complicated. So if this is true, then we're going to say print yes. This is the new line character, by the way. X and y. I want to make this easier for us all, because ain't nobody gonna understand what the fuck that means, but let's do this. There. Actually, let's just, here. It's even easier if we just do this. So we're gonna put this in quotes so you understand that we're printing this. Probably the easiest way to make sense of that. And, oh, hold on a minute. There we go. And we're going to have an else case. Else. We're going to print no. Quite that simple. Wait, is it smaller case or larger case? Looks like it's smaller case. Alright. Does that make sense? Is the one person that's here on the same page? I'm just going to assume yes. Right then. Okay. This seems like it should be relatively simple. Oh. Well, you're a new individual. I don't know if I've seen you before. Welcome to the stream. I honestly kind of just assumed that you were one of the friends that I posted this to. What a pleasant surprise. Alright, so now let's get on with this. Let me just double check everything. I could bring this into the program with me as notes, but we'll just go one step at a time. Save this. Go ahead to main. Okay, so first thing we need to do. Whoa. Okay, first thing we do, fmt. Why do I have 95%? Oh god. Interesting. I'm not going to pretend to understand any of that because I don't. Anyway. My CPU usage jumped again. NeoVim should not be using that much CPU. Something else is happening. I just don't know what. Alright, we might have to be raw dogging this. Oh, what is it called? Dear Lord. LSP. Oh, shit. We're still doing ours? Hello? Interesting. Oh, my CPU usage is at 99% again. I love it when that happens. Somehow, okay. I have a lot of difficulty doing these code challenges. I think I haven't learned to think right the right way yet. Seeing how someone else solves the problem helps a lot. Really? Well, I'm really glad. I really hope that you can hear me right now, because YouTube is saying that I'm having some buffering issues. Let me get out of NeoVim. I don't know why NeoVim is having issues, but it definitely appears to be related to NeoVim. Okay, the stream seems to still be running, but yeah, so honestly, my best advice, I'm not any kind of professional yet, so take my advice with a grain of salt, big grain of salt, in fact. But really, I think you should do what I did. I started off at the lowest possible level. And how do I explain this? You should try to take it piece by piece. The way to handle these problems are to piece it apart, just like how I just did. And if you don't understand something, or if, like, say for example, you find that you don't understand how to do a section of it, but you understand everything else, then just look it up. Don't be afraid to look things up. That's something that I'm struggling with sometimes, is I'll prevent myself from looking things up because I feel like I would learn better by not doing that. But sometimes if you just literally don't know the material, you gotta look it up. You know what I mean? There's no shame in it. But yeah, no, I mean, we're all on this learning adventure together, and I don't pretend to be any kind of professional, to be honest with you. I'm learning too. But I think it's all about just breaking the problem down. You know what I mean? Having notes is huge. I started making that notes. I started making that notes file around the, I want to say the 1100 range in codeforces, because they get so complicated that you can't really like keep your idea in your head, if that makes sense. You got to like note down some of your ideas and think through them. You know what I mean? But like below 1100 ranges, I don't think you need to think through them as much. You just need to know what the solution is, if that makes sense. The 1100 range and below helps you learn some basics, and I recommend just looking some of them up. Yeah, and yeah, I would stick around the 1100 range for a little bit and then go up, because I'm struggling up here, to be honest, in the 1300 range. This problem actually seems relatively simple, though, for the most part, compared to the ones that I've done before. Alright, hopefully this time my CPU won't spike into oblivion. No, it's spiking. I wonder what's happening. Hold on a minute. Let's do this. Whoa, what the... I didn't know that I was doing that. Alright, B top. Let's see what's happening here. Oops, nothing is happening? Well, according to this, nothing is happening, but according to this, something is very much happening. Alright, let's not do CPU direct, let's do memory. Nothing seems particularly odd here. I'll leave that open for now. It doesn't use too many resources. Let's just see if it will let me work or not. Nope. My LSP still isn't working. That's fine. That's fine. You know, sometimes maybe it's not such a bad idea to just kind of get back to basics, you know? Import? Is that it? Somehow that doesn't seem right. Nope. Import, there it is. FMT, nope. Nope. FMT, I think that's the import. Imported, not used, okay. fmt dot hold on. First of all, so by the way, I should probably mention we're using Go in this example. I like Go, super simple. I have dyslexia, so less code on the screen is usually better for me. But it's kind of like a C++ alternative if you don't know anything about it. Super fun language though, in my opinion. Definitely worth trying at some point. But anyway, so we're going to initialize a variable. We're going to do var. So we know that we're going to need n. We're going to just go ahead and do that. We're going to know that's going to be an integer. In Go, we just do int. So in Go, in case you're familiar with this type of thing, in Go, int is just automatically the largest integer you can have on the system. So in my case, that's a 64-bit integer. Yeah, Go is really fun. It's a really fun language, a really simple language too, but it's also low level. It's a compiled language, and it compiles really fast. You're going to see here in a little bit how fast it compiles. It's kind of scary. I don't know how they do it. It's a fun combination of like a scripting language and a compiled language. But yeah, definitely worth trying. Let's see here. So we're going to do fmt scan. This is how we get in Go. This is how I would get my standard in. So we're gonna do and in. Now I'm gonna be completely honest with you right now. I only messed with C a little bit, and YouTube is not receiving enough video to maintain smooth streaming. That's not fun. I've only messed with C a little bit, so I don't really understand dereferencing and referencing all that well, but my understanding is basically this and symbol right here. Essentially, I think that's a pointer, if I'm not mistaken. Can I get some info on that? No information? Okay. Yeah, so if I'm not mistaken, that's a pointer. Let me see something real quick. Scan any... I think that's a pointer, if I'm not mistaken. We can look this up. Let's look this up together. Actually, I want to learn. I want to know what the hell this means. What does and do when used against a var and Go? I should know this, but I really don't, to be honest. I just do it every time I need something from standard in. Let's see here. Now, I might have misunderstood what I meant. Wait, what? That is that is not what I asked, is it? Okay. Let me think. That's not going to help. We may have to ask ChatGPT. ChatGPT is usually a little better when it comes to having a little bit of context. I don't like to use ChatGPT. I think that if you're going to learn to code, you should really limit yourself from using ChatGPT as much as possible. Oh, here we go. Here we go. This is maybe the answer we want. So in Go, the expression and x generates a pointer to the variable x. So I was right. It's a pointer, basically. This means that instead of working with the value of x... Yeah, I don't know what's going on there, to be honest. I honestly have no idea what's happening. I need to look into that because, like, I'm supposed to have full control over this system. This is a, in case it wasn't obvious, this is Arch and Hyperland. So, like, I built this from the ground up. This should not be doing anything I don't want it to do, but it is anyway. I'm really curious about that, but I'll figure that out. So instead of working with the value of x, you are working with the memory address of x, where x is stored. This is useful when you need to pass the address of a variable to a function, or when you want to modify the value of a variable indirectly. For example, var x int equals 5, var p. Interesting. the memory address of X. Huh. That's quite interesting. Anyway, so basically, we're pointing to N when we scan for it. Don't ask me why we have to, we just do. So that's scan just goes like one character at a time, assuming there's a white space of some kind, like so a space or a new line in front of it, basically, or like separating it. So it will just stop at the first number, in other words. So now we have N. Let's see here. So we're going to do, so in Go, we could do this nifty, this is new actually in Go, new-ish in Go, I should say. It's not really new, but new-ish. So now in Go, we can actually range. So we can do, let me remember how to do this exactly. I think it's, do I need I? Yeah, I need I. Range N, whoa, hello there. Range N. So this will basically just range, this will basically do a for loop. It will loop over N times, in other words. Just a super simple way. Normally in Go, we used to have to, and we will still have to do this to go backwards over it, by the way. But we used to have to do this. So like I equals 0. I is less than, I don't know, N. And then I plus plus. I'm sure this is very common in a lot of programming languages. I'm sure you recognize this. And we'll still be using this to go backwards, but we can range over numbers now, so that's really cool. So yeah, but before we do that, we actually need a array. So we're gonna do a. So in Go, another cool thing about Go is you don't actually have to do this var thing every time. It's really just there for fancy purposes, or if you want to initialize something as a specific type. Go is a strongly typed language. However, even though it's a strongly typed language, A can actually be initialized just by doing this little thing here as a, say, for example, make. We're going to make a, this should be an integer array. What was it? A billion? What is an int 32 go up to? I want to save memory here, just because I like to be practical, I guess. Int 32 goes above a billion, right? I'm not losing my mind, am I? Int 32s go up to 10 to the power 16, I think. All right. Oh Lord, I shouldn't be forgetting this. I should know this, honestly. How do I do that again? I think it's 2 to the power of 32. 4 billion, in fact, actually. Oh, but we're actually going to be, hold on a minute. I might not be able to use, let's just use an integer. Fuck it. I'm overcomplicating it. Anyway, int size of n. So in Go, I'm sure this is harder in some languages like C for sure. In Go, we can actually create an array of a specific size by literally just typing make and then the int, or like the type of array and then the size of the array. What's cool about this is in Go, unlike C, for example, it actually initializes as 0. So it initializes as nil. In other words, we didn't have to do this. Like if we fmt print line, or print in general, is actually, by the way, standard out. So if we print line in right now, it would just print 0. It wouldn't print what was in the memory address before, like C does, for example. And so when we do make array of int, and Go, they're actually called slices, but it's a fucking array. I don't care. If we do make integer array, then it will make a zeroed out array. So everything will be 0. Not that that matters in our case, but because we will be filling it. Like, it's not a big deal, right? But still pretty useful for some things. Anyway, so we're going to do... This should be really simple, actually. Wait, let me think about this. I can go up to... This shouldn't take too long, I don't think. We have to be careful because dealing with code forces, you have a bit of a problem. Some challenges actually are going to require you to use a buffered standard in, standard out. In this case, we're not going to need that, I don't think, because the inputs are really simple and there's not too many of them. However, in some cases, you will need to learn in higher end stuff how to do buffered input. So look that up if you run into timing problems but you know your code is pretty good. Look up buffered input. We're not going to do that this time because I don't think I need to. It's a little bit more complicated to do that. Not that complicated, but a little bit more complicated. So, same deal. We're going to get the memory address of the thing that we're wanting to put from standard in into. And then we're going to put I, because what we're really doing here is we're turning I into whatever index we're ranging over. So if we range over n, we're going to range over whatever n is, like n times. But we're going to do it starting from 0, like most programming languages do. We're going to do it from starting from 0, and I is going to start at 0 and go all the way up to n minus 1, basically. Which means we can use it to build an array, just like this. So this is the simplest way to build an array. Now this is slow, like I said, but it's fine, because n is only going to be 100,000 at best. So we should be fine. Okay, now we have an array. Sorting in Go is also really easy, for the most part. Wait, let me think about this. There's actually a newer function we can use, I think. Hold on. I think it's slices. Yeah, slices module. Sort. Sorts a slice of a order type in ascending order. We actually want to do the opposite of ascending. This uses a function. Oh, interesting. So Go might have made this easier for us, actually. I didn't realize there was an isSorted function. We may not need that other array that we were building before. We may not need to sort it at all, because we could just check to see if it's sorted. We have to make a custom sorting function, but I can explain that. It's not too hard. We'll do that in a little bit. So actually, it turns out we don't need... We're going to go back to our notes real quick. We're going to change some things up. It looks like we are not going to need this right here. This step is not going to be needed, and we're really just going to is sorted. So there's a function literally called is sorted. So that makes things a lot easier. I'm wondering if I should... Anyway. So, that makes things a lot easier. So now we just need to implement our logic. Let's see here. Let me think about this. We can actually do this while we look for the variables. I just realized that. Yeah. So we can actually go in X and Y. So in Go, you can also initialize multiple variables as long as you want them to be the same type, which is pretty cool. So we're going to go, let's see here. Excuse me. I was just drinking some soda. Oh, Lord, the brain is starting to slow down a little bit, but that's okay. I got this. So we're going to check the next thing. Actually, if that's the case, then we can't really do this at the same time, can we? Yeah, we can. Yeah. Yeah, so if A, how did our thing go? So we need to know if, oh Lord have mercy, this is why notes are so important. See, my memory is probably worse than most people's short-term memory, ironically. You probably remember exactly what to do, ironically, and I don't, even though I made the damn notes. So we're going to be checking to see if the current index is less than... Now we're going to see if the current index is greater than the previous index. Yes. Yes, that's what we need to know, I believe. See if the current index is greater than the previous index. Now, here's the thing. In case you don't know, we have to use a max function. Why? Because in this case, if we go... Well, actually, there's an easier way to do this. Hold on. And less computationally heavy, actually, come to think of it. So we're going to do I minus 1, which will go to the previous index. Now, if we do this, on our first index, it will go -1. There is no such thing as a -1 index, obviously. So we can't have that because our shit will crash. But don't worry, I'm going to fix that in a minute. But let's just say, okay, so if this is true, then x will equal I. Because we want the index. Yeah. Declared and not used. Well, that's true still. Okay. I'm trying to think here. Why don't I have to do the same check every time anyway, actually? Yes, I will, I think. I think I will have to do the same check anyway. So we're just going to do a max function. Would a max function be faster than... Not really, they're the same speed, honestly. There's a few different ways we can do this, but we just basically want to make sure that we don't go too far left or right of our array, because otherwise things will get angry. I'm sure you know this if you've done any amount of programming, honestly, with arrays. But, yeah, I'm just going to do it that way. It might be a stupid way. Sue me. I don't know. What do you want from me? It will work, though. Trust me. So, yeah. So if that is greater than the previous one, then x will equal I. Yeah, that should be fine. Okay, so doing y will be a little bit more difficult, I think. Will it? Perhaps not. Sorry, give me. I'm in the middle of thinking. I keep forgetting I'm streaming. Okay, so we need to do kind of the same thing, but the problem is with y is I think. No, it should be fine. We should be able to do it this way. So if I is... Ooh. I just realized something. We have a slight problem. I think we need to do the same kind of check, actually. And also, actually, wait. Sorry, give me a second. I'm trying to think about this. So if we do this, then technically we need to find a way to stop. Okay. So this might not make a whole lot of sense at first, but X will continue to get turned to I, it seems like. Because if we recall our example, let's go back to our notes. We're checking to see if we should turn an index into X, or X into an index, sorry. If the index that we're on, the number of the index that we're on is greater than... Is it? Wait, no. Wait, what? Wait, 2, 3, 4. Shouldn't it be less than, actually? No, we're going in... Huh? Yeah, that's right. So, if the number that we're on is less than the number that is in front of it, I just realized I did my code wrong in that case. It's less than number in front of it. We actually need to do a min function instead of a max. Min is the opposite of max, basically. In this case, n minus 1. Because n is a regular positive number, but arrays work from 0, not 1. So they start counting from 0, not 1. So you want to minus 1 from n, even though we know the size or whatever. Anyway. So if AI is... Yeah. Then X. Okay. We still have the same problem, but I need to fix that because I'm a little dumb. So basically, the problem obviously is that basically we're checking to see if this number is greater than this number. And then we set this number to X. But if we keep checking, then we'll find that this number is still greater than this number, and then this will become X. And then this will become X. And then this will become X. I imagine you see the problem now. So we need to stop it at the first instance, basically. It's relatively simple. Y, however, will continue. So once we get to 6, we'll say, is 6 less than 1? And we'll go no. That's when we'll set Y. If that makes sense. Or actually, we could just keep setting Y until we get to this point, and it won't set it anymore. So, yeah. But we need to stop from counting X. So actually, we don't even need this. What we can do, actually, is we use the same if statement. And then we're going to create a new variable. This is probably a sloppy way of doing it, but listen, man, I'm new to programming. What do you want from me? So we're going to say if first, yeah, why not? Then do that. So this is going to be a Boolean value. And we're going to set this Boolean value right here. Var first. It's going to be a bool. Remember that Go defaults to 0, and in Boolean logic, it's going to default to false. So at first will be false to start with, and then we're going to say if this, then that. Do this two ways. So in Go, you can also do this, for example. Well, we already explained that. So we could do this. We're going to do that instead. So instead of initializing it to false, we're going to initialize it to true because it's the first time. So if first, which is true, then execute X. And then we're going to say first is false. Now it's no longer the first time. So now if we run this again, it will go, uh-oh, this isn't the first time we did this. Now, let's do something else. Let's say else. If it's not the first time, then we actually want to set y to I. This way we're not copying and pasting this, because this is not super computationally heavy, but we don't want to do this 2 times if we don't have to. You know what I mean? Because we're already checking this as well. And since we're kind of doing the same thing anyway, we might as well just go ahead and use it. And so as soon as we get to the first instance of this not being true, y will be set to the right place anyway. I hope that makes sense. To be totally honest with you, I'm probably making less sense and less sense as we make this because, like I said, my short-term memory is kind of crap, and so I struggle to explain it to myself sometimes. But anyway, so we have x and y, which makes things a little easier. And we also have our array, so that makes things easier. So we're going to go ahead and this for loop is over with. Now what we're going to do is we're going to swap that. So we're going to make a new for loop. And this is going to be pretty simple, and Go makes this pretty easy. So for, let me think about this. Y minus x, yeah. So I think I equals range. No, wait, we can't actually do that. We need to do I will equal x because we want to start here. Okay. So I will equal, well, starting at x, basically. So long as I is less than, I think we need to be less than or equal to y. Yeah. And then I plus plus. So this is that standard for loop I was telling you about. It makes sense? Okay, good. Thank God. So this is the standard for loop I was telling you about. This is what we would usually do. The reason I'm doing it here is because with the range statement, or at least as far as I'm aware, in the range statement, you can't actually specify like a start, and I will always be starting from 0 with the range. But in this case, I can start as x because we're setting it to x, and then we're checking to see if it's less than or equal to y because we want it to stop at that. And yeah, and then we're I plus plusing, or I incrementing. So now all we have to do is, in Go, like I said, Go makes this pretty easy. We're going to do A. Oh shit, wait a minute. I just realized something. Hold on, let me think about this for a second. I'm not doing this quite right. I'm not doing this quite right. We need two variables. We need I and j. We need to be equal to x and y. This will still be correct, I think. Actually. What am I doing? Oh my god, guys. Dear Lord, I'm losing my mind. I'm losing my mind. We need to go over it backwards. And swap them. Right, okay. Sorry. Let me think about that. So we need one variable to be going forward, one variable to be going backwards. So actually we do still need two. I'm not entirely crazy. Just let me cook a little bit here. Oh, whoops. That's still correct. But what we also want to do, I don't know if I can do this. I'm going to try j minus minus. I can do that, okay. Cool. Okay, so basically we're going to be walking forward and backwards at the same time. Does that add up? And actually, I think we want to stop once they clash. Less than or equal to j, not y. I think. Hold on, let me think about that for a second. Yeah. Okay. So now we get to the easy part. So AI, remember how I said in Go setting variables is relatively easy? Well, you're about to find out how easy it really is. So in some programming languages like C, you would need a temporary variable for doing this. But in Go, you can swap things just by, well, literally swapping them. Like this. And boom, that's it. I just swapped them. So basically what I just did, all I did really, is I said I'm going to switch AI with AJ and AJ with AI. And like I said, we're going backwards and forwards at the same time. J is going backwards, I is going forwards. Real simple. Yeah. Should be right. Yeah. I believe that's right. And I think once they get ready to clash, so once I is less than or equal to j, no, while I is less than or equal to j, actually maybe not equal to, wait, hold on. If it's equal to j, then... Whew! My brain is not working right now. If it's equal to j, then that would mean that they're on top of each other, and we don't really want to swap the thing by us. Yeah, okay, that's fine then. Alright. Where are we? So now, finally, we're going to use the very last step in this process is we're going to use the slices, dear Lord, the slices package to, whoop, hello? My brain really is going to catch on fire. Did I not? Hello? Why is my LSP doesn't seem to be working again? Oh no. Oh wait, what? Expected, found. Oh, I see. This is okay, so you can't actually do this then. That's fine. What we can do instead is it's kind of the same thing. Okay. Is sorted function. Or whether X is sorted in ascending order. Okay. What it goes here again? So we need the slice. What the hell? So X for the slice, comparison function, integer, bool. What? Oh, I see. Okay. I think I see anyway. So basically just A, and then func, integer. Hold on a minute. I and J and shouldn't we be? Uh-oh. Wait. It's for whether X is sorted in ascending order with comparison as the comparison function is defined. But isn't the comparison function supposed to output a Boolean value? Why are we outputting an integer? Oh god. Okay. So, we are going to have to do some chat GPT because I don't know how to use this function, but this is clearly the fastest way to do it. I could try it, but I don't actually know if this would work because no, I know it won't work actually because let me check something. I'm used to I don't understand this. So usually comparison functions are actually Boolean. They output Boolean values, but in this case we're not outputting a Boolean value for some reason. So I don't actually know how to make the comparison function in this case. So we're just gonna ask ChatGPT as much as I don't want to. As much as I don't want to, sometimes it's just what you gotta do. This isn't gonna show something important. Ooh, hold on a minute. I should probably do this in another tab just in case. Because I'm not 100% sure I haven't done anything like dumb in there recently. Give me a second. Just double check that there's nothing funny going on. Let's see here. How to make a give me a second here. I don't think there's anything like private. I don't think I would have put anything private on ChatGPT. That wouldn't make any sense. Oh. So this seems convinced. See, this is what I'm talking about. This is why AI can be a little funky sometimes. It wants to make a function that outputs a Boolean. But in this case, if we tried to do that, watch this. In Slice's code, okay, so hold on, let me read you the missing return. So in call to Slices dot is sorted func type func blah 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 bool of func blah 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 bool does not match inferred type function int for function int cannot infer type args. So in other words, it's saying it's the wrong type. We're outputting the wrong type of the function. So, oh shit. I just now realized I was missing some comments, my bad. I program in JavaScript, TypeScript most of the time. I make websites for small companies, mostly static sites. There's a lot of syntax sugar in JS that makes it easier. These facilities make it difficult to learn programming logic. Do you think that learning a low-level language will boost my programming logic to learn how to solve code problems of this type? Yeah, honestly, yes. My honest opinion, and like I said, I am not super like experienced or anything, but my honest opinion is that when it comes to web design and when it comes to honestly UI design in general, a lot of times you end up doing a lot of the same thing. And so it's more of a memorization game than it really is like a logic game. So really, if you wanted to improve your overall like programming logic, then yeah, I think a lower level language, like just honestly, probably just a compiled language would probably be what you want. Something like Go, something like C, C++ if you really want to, though I wouldn't personally recommend it. That's just my personal preference, though. Something like that, because that gives you, those languages are mildly better for this type of thing. But if I'm being honest with you, you can do it with any language. But just doing these problems in general will help you. Doing it with a lower level language will help you understand like the computer better, help you understand like how the computer might be thinking. Something like C would be really good for that. But it's not really necessary per se. It could help you in making notes and like breaking problems down though. So like I think, yeah, if you wanted to really get into like logic and stuff, I would probably, you know, mess around with C for a little bit until you understand the basics. And then maybe move to something like Go, which is a little bit easier, but still like kind of, how do I explain it? What's the word I'm looking for? That's still kind of logic oriented, still kind of low level, I guess you could call it. Go is interesting because it's like on the borderline between low level and not really being low level. It's kind of funny. But like, yeah. I think Go would be a good start though. I don't know if the language really matters that much at the end of the day though. I think it's just like, you know, if you want to improve your logic, you just kind of do leet code. Start from the bottom up. Don't try to do too much at once. And try and understand it. Like you can look things up, but make sure you're trying to understand what you're looking up. Like yeah, I'm looking up this function right here. This isn't even explaining anything, by the way. So this is just false, but like I would try and understand what it's doing here. Like, why is it doing that? Why does it want me to do this? You know, think like that. You know what I mean? If that makes sense. Because a lot of times with web design and like UI, or at least I haven't done a whole lot of it, but what I have done of it, I feel like it's more just like, you know, oh no, that's fine. I don't mind. It's not a big deal at all. And honestly, I'm still trying to figure out why the hell this function wants to output an integer. But yeah. So where was I? Lost my train of thought all of a sudden. Yeah. Basically, just kind of focus on leet code, and you'll get better at it. Is really what I was trying to say. Let's see here. Why does it want an integer? Let's try this again. Let's try this again, but let's do a search and reason. Determine compare function. Close an example in Go that demonstrates how to. Once again, it wants to output a boolean, but this function does not want a boolean in the comparison function. Why does it not know this? What the fuck? This is so useless. All right. All right. Let's do our own research real quick. Let's see here. All right. So is sorted function reports whether X is sorted in ascending order, with comp as the comparison function as defined in sort func. Sort func. What is that? Is this some kind of standard? Hold on a minute. Let's see if we can help ChatGPT out real quick. Let's see if we can help it out. Might help it. Is that really it? Is that all it is? Is it just a negative one, positive one? Are you kidding me? All right. I'm going to take its word for it. I'm going to take its word for it. So normally we would use booleans for these functions, but for some reason in this particular case, according to ChatGPT, which should be taken with a big grain of salt, like a big, like grandpa pill-sized grain of salt, by the way. Yeah, so we're going to be doing return I is greater than J. Oh shit, never mind, wait a minute. If I is greater than J, return one. If I is less than J, return -1, I think. And then return 0 in the default case. I don't think this is gonna work. I'm gonna put this out. This probably ain't gonna work. I'm gonna just let you know. I don't think this is how this works. I think ChatGPT is legitimately smoking the largest blunt in history right now, because I don't think it knows what the fuck it's talking about. I'm gonna be honest, but let's hope that this is how it works, because that would save us some time. So I just realized, so this actually, in case you didn't notice, this actually outputs, hold on, this actually outputs a Boolean. So notice here, this function outputs a Boolean. So what we could do actually is if we just do if, I don't think I can do that actually. It'd be confusing if I did. Let's just put this in a variable. So just like how we initialized our first Boolean variable into true, we're initializing is sorted variable into this right here. Okay. And then if is sorted, then we will fmt dot print line. Actually, we're going to do print format. So print f. So that's for print format. We're going to do yes. Sorry. Yes. New line character. I'm sure most of you knew that. And then we're going to do %d. So if you don't know, I think this is some kind of standard. I'm not sure what standard it is, but %d is just integer. And we're going to do another %d for another integer. And now we need to tell it what integers we're going to be printing. So integer number 1 is going to be x minus 1. Sorry, no, plus 1. Because we need a natural number, not an index starting from 0. So y plus 1, because it wants a natural index. Notice, we can actually double check real quick. Notice that in this example right here, for example, it's saying that index 1, which is 2, and index 2, which is 1, needs to be flipped. So it wants a natural index. Otherwise, 1 would be 0 and 2 would be 1. These are indexes. So it's important to watch out for that because codeforces will mess you up. Else, we're going to fmt dot print line. In this case, we won't do a printf. No, because we're only doing one thing. So at this point, our program should be done. However, it's probably not going to work. I'm going to be honest with you. Listen, this is just the nature of programming. So we're going to get our example there real quick. Since we know what the output of our example should be. It should be 2 and 6. Yes, 2 and 6 is what it should output. So in NeoVim, I can actually open up a terminal like this. Do go run. So this is the cool thing about Go. Watch how fast it compiles this. It does it instantly. I know it's a small program, but like it does it so fast it's stupid. Main.go. Oh, hold on. We got to pipe it. So we got to do echo. That's our example. And then we're going to pipe it. So that's just standard in right there. And it's also, that took a long time to tell us no. Why? What? What the hell? Oh, okay. That's wrong. It's obviously wrong. Let me just try something. I'm gonna give it a shot. I might have this flipped, not gonna lie. Yeah, Go is really cool. Okay, so something's really fucked up about this or this. So let's do some debugging. Debugging time. I think we might potentially have a problem here. Let's check this first. Print line. So Go again is really simple. If I just type in A, that's our array. It will just print out the array. Watch this. See, there's our array. So 7, 2, 3, 4, 5, 6, 1. We did not swap the variables. Oh, shit. I see the problem. I see the problem. We're supposed to minus 1 here. Or at least that's a problem. I don't know if it's the problem. 7, 2, 3, 4, 5, 6, 1. We're not swapping the variables. Why are we not swapping the variables? Let's print some more information. X, Y, and A. Oh, X and Y are 0. Interesting. So it's actually not this at all that's fucking up. Why are X and Y 0? Let me just check something real quick. Clearly this if statement's fucking up, but I'm not entirely sure why just yet. It's probably something simple. My dyslexia is probably fucking with me. Let's see. 1, 2, 3, 4, 5, 6, 6. Yeah, that's fine. Okay, so nothing wrong with that. We're asking if the current index is less than the next. Oh my god. I'm such a fucking idiot. I'm checking an index that doesn't exist yet. I haven't set. I'm scanning and setting the thing. I haven't set the fucking thing yet. Because I'm plus 1ing, I should be negative 1ing, or minus 1ing. I should be max functioning to 0. And I should be flipping how I'm checking it. So, let's see if that helped. Wait. Hold on a minute. Give me a second. I want to... Ah, shit. Okay, hold on a minute. What the fuck? Alright, there we go. Okay, so now we're getting somewhere. Let me see if we have Y and X, though, real quick. Two and 5. That's not right. That should be 1 and... Well, 5 is right. 2 is wrong. Oh, wait a fucking minute. No, that shouldn't be the case either. What is going on? That shouldn't fuck up. Wait. Oh, debugging, how I love you, my beloved. Alright, let's see what it does. Let's do this. fmt.println. Actually. So it first initializes on 2, not 1. Why? So it initializes here, so it's saying is greater than... I see. Okay, it was just an oopsie daisy on my part. Just gotta do a -1. So it's the previous one that we actually want, it seems like. Let's run that. Hey, there we go. That's a working program. Needs a little bit of formatting, but yeah. There we go. That's what I'm talking about. Okay, let's change the input a little bit to something we know won't work. Alright, we know this won't work. There we go. Alright, I appreciate it. I don't rock that well. I feel like somebody else, one of my programming buddies would have definitely been able to do that in like an instant. But, you know, hey, it's all the learning process, right? All about the learning process. Give me a second to take a celebratory mint before we try and test our program. Now, here's the thing, okay? When it comes to codeforces, they like to throw, and I get the feeling you know what this means, but I'm just going to explain it anyway just in case. They like to throw edge cases at you, which are situations where you normally wouldn't expect the logic to fuck up, but it does in a way that you wouldn't expect it to. So even though it just worked right then, that doesn't mean it's going to work in every possible scenario. However, that was why we did the notes. It doesn't guarantee anything, to be clear, but the point of the notes at the beginning of this was that we wanted to thoroughly think through our logic first. Thoroughly think through the logic. Because if you don't, and you just start trying things, when shit fucks up, you're going to be confused as to why. And so it's important to think through your logic and have a really solid foundation. Now, having said that, I'm probably going to fail this test. It could be due to time, or it could be due to a logic error. I might have a logic error. Listen, man, I didn't say I was... Whoa, what the fuck is happening here? I didn't say I was some super genius, okay? What the... Can I... Hello? What? What is happening? This doesn't usually happen, I swear. And I can't resize it. That's really weird. I have no idea what's happening right there. Let's just... There we go. Not day 16, day 17. May not go. Okay. Let's see what happens. My bet is that I'm gonna bet. Wrong answer on test 1. Uh-oh. Wait, what? Didn't we just test this? It should have definitely worked just then. What? I wonder what in the world is going on here. Look at them edge cases, bro. I told you. I told you that was going to happen. That's the thing about coding, is that you'll run into edge cases. See, we just tested it and we confirmed that it worked, but suddenly it's not working. Now, I'm guessing it has something to do with the size of the array. Let me think about this. Wait, what? Oh, shit. Wait a minute. Oh, no, wait. Oh, no, wait a minute. I think I might know what the problem is. We might have needed to check if it was assorted least to greatest, not greatest to least. Oh, shit. Oh, no. God damn it. I thought it was the other way around. Alright. Well, this is really easy to fix, but it's really embarrassing. I made that whole function for absolutely no reason. This function right here, useless. Matter of fact, this entire thing is useless. Because we only need this function. We just need to put that in. We were sorting the wrong way. Wait, what? Oh, right, of course. I need to flip-flop my logic here as well. I think. Voila. Alright, let me just make sure you don't do what I just did, and make sure you do the examples that they give you. Because if maybe you did your notes wrong or something like that, like I did, I'm a little, I'm not all there. No, that should have been yes. Why was it no? Okay, here's another edge case. Probably because the indexes are so close to each other, I bet. Print line X and Y. Let's see. What? When is less than 2? So it should have... 3 is greater than... Oh, shit. Okay. I know what the edge case is. So if it's less than 2, or if it's 2... Yeah. If it's less than 3, then what will end up happening is that it won't run into this if statement again. Because of reasons that I can't be bothered to explain, apparently. So what we need to do is we also, when we set x, we need to just go ahead and set y. It's fine to do it. It will change if it needs to. Otherwise, we have it. So y will be equal to, not y, will be equal to I. Yeah, will be equal to I. Let's see. And then there you go. Now we have another, now we fix that edge case. Okay. Let's see here. Okay, so this should output no. Let's see. Okay, it outputs no, good. This should output yes. I don't think our code should mess up here in theory. There we go, okay. Perhaps we gotten through all the edge cases. Maybe not. We're about to find out. Drum roll, please. Oh, is this going to be a second try situation? Hey, second try. Let's go. And there we have it. On our second attempt, after just a little bit of debugging, we have our answer. So how long did it take me to do that? Probably a while, I bet. Whew. Almost an hour and 20-ish minutes of coding, it looks like. That's not too bad. So it's been 2 hours so far. I wonder if I can knock out another one. Perhaps. I don't like the speed on this bad boy, but that's to be expected. That's probably because of, whatchamacallit. I just hope we don't run into a problem that requires buffered standard in. I'm not actually used to doing it that well. I might have to dig into another program to use that code. That's another thing. If you do get into doing Go, if you do get into doing like these problems, don't be too afraid to dig into your previous code. If you've already figured it out, there's no reason for you to try and figure it out again. Just go ahead and copy the code you had, if it will work, and then just kind of try and memorize it. Not memorize it, but, you know, try and refresh yourself on it. If you understand it, then you can copy and paste it. If you don't understand it, then for the love of God, don't copy and paste anything. Unless, like I said, you know, you're doing like production work. You kind of don't have a choice. But I don't even know if you copy and paste stuff, but I feel like most people do. Even in production work, you probably copy and paste a lot of code. I assume. Forgive me if my assumption is incorrect. Oh, or another sorting one, an implementation. Yeah. Yeah, back-end code, there's a lot less copying pasting in back-end code. I will tell you that. However, that doesn't mean that there isn't some. But try your best to copy and paste your own code rather than somebody else's, because you really want to try and understand it. It helps with implementation. We'll give this one a shot. Alright. I'm going to change the pin real quick. Alright, so that's the one we're working on now. We're done with this for now. So we're going to CD, and then we're going to do proj. I don't know if you use Linux. It's kind of a toss-up, assuming you do front-end, because I think a lot of front-end developers like to use Mac or Windows, but Linux is quite handy for things like this right here. I don't need to do day 18. We're doing day 17 still. We're going to do day 17.1 because, of course, it's beautiful that I just created an entirely new project directory with all of the files that I need in it, by the way. It even has a learning checklist. I use this when I'm not streaming, but this little learning checklist is useful. So I copy and paste this. What? Oh, I accidentally used Vim. NeoVim. So I typically use this. This is like I time myself. Linux Mint is perfectly fine. I mean, I have a little bit of a saying, okay? It doesn't really matter what distro you use, because they all use the same kernel. It's still Linux. You know what I mean? It's all Linux. So like Mint, Arch, whatever you're comfortable with. Arch is just like more advanced in my opinion, just because you have to basically build it from the ground up. But there's advantages to doing that, as well as better understanding you get from it. But like I wouldn't recommend that to everybody, you know what I mean? Mint is fine. Hell, you know, I don't know if you've watched the guy, but one of the coders that I mostly look up to, I don't really watch a lot of his content to be totally honest with you, but one of the coders that I personally look up to, which is dear God, Primogen, he actually uses, if I remember correctly, Pop OS. Now he installed i3 onto there, so it looks like it's some other distro, but it's Pop OS. You know what I mean? Like, he's not super big into Linux either, but he codes like a madman. But yeah, no, I mean, I don't really think it matters that much. However, what I will say, and Mint is good about this, so you don't have to worry about this, but I will say I would stay away from snap packages. I've heard good things, and I've heard bad things, but my personal experience with snap packages is they mess things up big time. For some reason, they're slow, and I have tried them, like the modern version of them. I've heard that they gotten better, but they really haven't. From my perspective, they're still slow, and they don't work all the time. But luckily, you don't have to deal with that. You're in Mint. Mint doesn't even mess with snaps. You can install them, but they're not default, so it's not a big deal. But the only distros I would stay away from are like Ubuntu and like no-name distros. But if you stick like with the big names, you'll probably be fine. It's not a big deal, honestly. It's all Linux. It's all the same shit. Different package manager. That's about it. But yeah, so I use this typically to kind of time myself, because I'm actually really bad, by the way, with not looking things up when I should. I like to stay in my coding zone, if that makes sense. Yeah, Snap is full of. That's what I'm saying. It's kind of Linux equivalent bloatware, is really what it is, in my opinion. Not all of it, obviously. Snap can be useful for some things, but like Ubuntu, for example, uses snaps heavily. It's actually their default package for a lot of their user-facing apps, which is really unfortunate because they're kind of crap. They're good for like one or two programs, but once you have a whole bunch of programs, it makes things just really bogged down and unnecessarily large, and it's not even safer. Like with Flatpaks, at least they're safer. You know what I mean? Snaps aren't even really that much safer. That's the funny part. So it's just kind of like an overall crap heap. But anyway, I think the other thing about it too is it's a little bit against the Linux spirit. And maybe you don't give a crap about that, and that's fine. That's perfectly up to you. But I personally prefer the Linux way of things, which is like open source by default and community ran, right? The thing about that is snaps are actually, I don't know if they're fully, but they're definitely at least partially proprietary technology, actually, from Canonical, which makes Ubuntu. And I think that's why a lot of people don't like it. But there are definitely legitimate like performance reasons for not liking it. But anyway, let's go into our notes here. Actually, no, let's get set up in our main thing here. Alright, so what are we dealing with? So, Pashmak? What? Pashmak and flowers. I don't know what that word is. Might be a name, perhaps? 1300. And the link. Uh-oh. My music is skipping for some reason. Well, it was strange. Right then. Off to notes. So, we get a 1 second time limit, 256 megabytes of RAM. That's pretty standard. Okay, so Pashmak is a name, it sounds like. Alright, hold on a minute. Wanted to pop a mint real quick. Let's see. Pashmak decided to give Parmidia a pair of flowers from the garden. There are N flowers in the garden, and the nth of them has a beauty number B, I. Parmidia is a very strange girl, so she doesn't want to have the two most beautiful flowers necessarily. She wants to have those pairs of flowers that their beauty difference is maximal possible. So the difference between the beauty is as large as possible, in other words. Your task is to write a program which calculates two things: the maximum beauty difference of flowers that Pashmak can give to Parmidia, the number of ways that Pashmak can pick the flowers. Two ways are considered different if and only if there is at least one flower that is chosen in the first way and not chosen in the second way. What? Is there like some notes? choosing the first and second flower, choosing the first and the fifth flower, choosing the fourth and the second flower. Oh, I see. Ah, okay, okay. Okay. This won't be too hard, actually. I think I know exactly how to do this. Alright, what are my inputs? So, 10 to the power of 5. I have a minimum of 2. Separated integers. 1, 2. Okay, well that's similar to what we were dealing with before. Could probably honestly use float 32s to reduce memory usage, but I'm not going to bother. Actually, we are going to use float 32s, but not in the way you might be thinking. I know exactly how we're going to do this. The fastest possible way, in fact. I think it's the fastest possible way anyway. Actually, wait a minute. Alright. Well, there's always the VOD. We're currently at 2 hours and 17 minutes, it looks like. So, if you wanted to come back to this, you can. I think this was going to be relatively simple. It might not seem like it to you, but if you watch the VOD, you'll understand why I think it's simple. But yeah, good night, and good luck tomorrow on whatever it is you're doing. Alright, so let's see here. Oh, well, I appreciate that. And I'll try to keep regular in that case. If I only have one regular, that's all I need, honestly. The idea that I'm helping somebody, or just even kind of going through the same journey, is it's pretty fulfilling, believe it or not. So yeah. But yep, like I said, good night and good luck. And thanks for watching. Okay. So I think you rock too, man. So I think what I'm probably going to end up doing here is I'm going to be creating an array that's... Oh, no, wait, I can't do that, actually. Actually, I'm going to keep track of two variables. Each variable is going to be what we call a vector, which is really just a slice of two. So it's just two items in one. The vector will contain an index and no, not an index, sorry. The vector will contain a number and an amount of that number. We're going to find the minimum number and the maximum number And we're going to count how many of those there are. The only problem is I might have to load the whole array in first. No, wait, let me think about this. Actually, we don't have to load the whole array in. Because if we find a bigger number, we don't need to worry about how many of the smaller numbers we had before it. It's just completely irrelevant. And then we just calculate the amount of possible combinations, which isn't too difficult. Yeah. Okay. So this is going to be a relatively simple note section. So all we're going to do is as we get the numbers, we'll look for the minimum number and maximum. Whoa. Maximum. God, I can't spell. One moment. Thank God for NeoVim. Maximum number. Put them in index 0 of 2 separate vec2s. If you don't know what a vec2 is, I'll just put this here. Array ends. So it's just an array of size 2 integers. Or whatever. It doesn't have to be integers, I guess, but it actually usually floats, come to think of it. Okay. So we're going to separate, into separate vec2s. And the same number, then we'll increment the value in index 1, the vec2 respective vec2. Okay. So what we want to know is the difference. So will equal will equal max num minus min num. Yeah. And to get the total possible combinations, if I remember correctly, we can do that by 2. So 2 and 2. 2 times 2, which is 4. I think we can just multiply isn't there a word for that? Hold on, I'm trying to think. I think we're just gonna say amount. We're gonna say amount of ways for now. It's a big variable, whatever. If I'm not mistaken, the math is max num times min num. That should be it. Should be it, I think. Let me think about that for a second. Is it multiply by, or is it actually... It's not multiply by. It's actually to the power of, if I recall correctly. Oh wait, no, hold on. This isn't right at all. Man. Not a min num. What we need to know... As a matter of fact, these need to be indexes of 0. Alright, shit. These need to be indexes of 1. Yeah. That needs to be the power of that, I believe. Yes. Okay, that should work. This should be relatively simple. So we're just going to do var... What's our... So we have an n. That's good. Var in integer from t. Print. No. Scan. N for I. This is the same thing we just did a while ago. Range n. A lot of these codeforces problems end up kind of having the same start, to be honest, but not all of them. Alright, now we need something else, actually. We need a var max num min num, and they need to be vectors. Technically there's a thing for vectors, but we're just going to do slice 2. Okay. I don't need the index, I just realized. What I do need, however... No, I don't need that either. Um, we need another variable to grab or to put the scan in. Okay. And then we just need to check. Oh, yeah, no. Yeah, we need to check two things. The maximum minimum. If B is greater than max. Hold on a minute. Let me think about how to do this. It might make sense to actually use a switch case in this situation. Let's see if I remember how to do it though. I don't think I do remember how to do it. Hold on, we gotta look this up real quick. How to do a switch and go. Oh, I didn't need reasoning for that. Fuck. I just needed you to search. Thank you. That's exactly what I want you to do. Alright. Switch. Oh, that's right. It's got to be. Of course it does. Of course it does. Of course it does. Okay. Switch B. This case. B is greater than maximum. No, we're actually going to say case maximum 0. Maximum 1 plus plus. Yeah. We're going to do the same thing for min-num. Okay, we're going to do another case. Oh. Maximum 0 is less than B. In that case, we're going to do maximum 0 sorry, YouTube is screaming at me about something. Will now equal B. And you know, let's speed this up a little bit. Wait, what? Cannot convert untyped bool value to type int. Huh? I thought you could. Can you not do that? Oh. Oh, come on. Alright. Fine, be that way. So I have to change this a little bit. Okay, now we're just gonna swap max num. Swap that with min num. If min num is, if max num is less than b, if min num is greater than b. No, wait, that doesn't make sense. That does make sense. Oh, Lord, I'm losing it. Alright, so that should be our switch case. I think. Oh, wait a minute, we're missing some things. We need to actually do this as well. Otherwise, it will be 0, and that's not what we want. Okay, that should give us the maximum and minimum numbers, as well as the amounts that exist in the array. Which in this case, we're not even making an array, actually, so... min max num. So I just really quickly want to test to make sure we're actually sorting this correctly. I don't want to get too far ahead of myself like I did before, so let's just try this one. So the max num should be 3, the minimum number should be 1, and we should get 2 of each. Uh-oh. Oh, right. We need to initialize the maximum number as something big. Sorry, minimum number. So let's do this. We're actually going to initialize it. We're going to say it's to int. We can initialize it like this. It's going to be 1e9 and 1. Those will be 0. So that should fix that problem. Okay. Why is that 3? Why is there a 3 there? Oh, shit. Right. This is wrong. We need to not plus plus, we need to equal to 1. Huh? Oh. There we go. Whoopsies. My mistake. Testing is important, people. Right then. So there we go. quite a simple little switch case situation there. Now all we have to do is do a little bit of math. Matter of fact, we can do the math right here. So in our case, we're going to do max num 0 minus min num 0 max num 1 to the power of min num. I think it's to the power of it anyway. Is it to the power of it? I hope so. That doesn't seem right. Oh, of course it's not right. That's not how you do that at all. I think it's like this. Why? Alright, let's do this. So this is just a little function that does the power of. So x to the power of y, basically. And we need them to be floats though, so we're just going to cast them into floats. Float 64s. I'm gonna be honest, I don't trust that that's right, but it might be. Oh, what the heck? That was a total accident. Alright. Is that right? Yes. Seems a little too simple. I'm not gonna lie. Doesn't feel quite right. I get the feeling we're gonna run into an edge case, but screw it. Let's find out. Nothing to it but to do it now. What? Didn't I just test this? Oh my god. Well, I tested the longer one, to be fair, I guess. My code doesn't work on things too small, it looks like. Why? Whoa. What in the world? Huh. Not totally sure what's going on there, gotta say. So, should be doing 2 minus 1. Which should be 1. Well, that's not right. Our minimum number stayed as... Why did that happen? I think I see the problem. Switch cases can only do one of the 4 things, or one of the things that you do. It won't do 2. So maybe a switch case wasn't the best option for this, but I'm gonna roll with it anyway. But what I'm gonna do instead is just make another switch case. Even though a switch case with only 2 things in it is kind of dumb, but like, I don't know, sue me. What do you want? Let me think about that for a second. That'll probably work, but I wonder if I should change it to like an if statement or something. Would an if statement make more or less sense here? An if statement would make a lot more sense, actually. If, equal to be num is equal to b, then do this. Else. Do this. That should work. Makes a little bit more sense to just do a if statement like this, honestly. And there we go. Should do the trick, I believe. That way we're checking for max and min, because sometimes we need to set them at the same time. Sort of. And there we go. That should perpetually fix our problem. It's a pretty quick little check too, so. Let's try it again. Wrong answer on test 4. Isn't that the first thing we tested? Maybe my new code fucked it up. Oh. Plus infinity. Interesting. I'm guessing I probably did it wrong. What am I talking about? What makes sense that it'd be squared by it? Why would I square it? All I'm doing is I'm checking... I'm checking the matrix of these. If you do a matrix, then that's all possible combinations right there. Yeah. I don't know why I had to think so hard about that in the first place. I had a feeling I did that wrong. Oh, math import not used, of course. Third time's the charm. Please excuse my limited understanding of basic math. Wrong answer on test 5. Interesting. What the hell? Now what? What? Oh. I didn't expect this, I'm not gonna lie. So in the case that they're the same number, you need to be careful about that. Wait, hold on, let me think about this for a second. What do you mean it's not called? What does it mean it's not called? Is this... Can I not do this? Is this not allowed? I thought this was allowed. Well, I can call a function. Oh, right. Right. I almost forgot. You gotta put these here. For the function to be called. Don't forget these little things. Radio. Isn't the number... Hold on a minute. If 1 and 1, then it would be... one possible combination. Let me think about this. There's an easier way to fix this. This is starting to look like spaghetti hell, but it is what it is. That ought to fix the problem, I believe. Yep, that does appear to be the answer, I think. Yeah. That sure did seem to fix the problem, though I feel like it's going to introduce another problem later down the line. Let's find out. Time limit exceeded on test 6. Very interesting. Now, how could that be possible? Wait, what? I thought it could only be 100,000. Shit, I might have to use a buffer in that case. Wait, but I did output something. What? What in the world? Did I misunderstand something? I thought that the limit was 100,000. I must have did some math wrong in my head or something. It's 2 times 10 to the power of 5. Well, that's indeed a problem. Damn it all, I have to use a buffered input. No big deal, I can look this up real quick. It's really not that hard. Give me a second. I think I did it on day 16. Never mind, I did not do it on day 16. I probably did it on day 15. No, 15.2 perhaps. So I need that. Oh, crap. Oh, there's two ways I could fix this, and the easiest way I could fix it is probably just do this. How's it going? You know, just buffering some input. Not really, to be honest. I think I've already solved this problem. It's just a matter of buffering some input, since I think the standard in was a little too slow. I think I already have it, though. The last one was a little bit more challenging, I think. This one doesn't seem too hard. There might be more edge cases than I'm aware of, though. But I feel like I got all the edge cases already. Alright, well, let's see if I'm right. Handling inputs is always annoying. Have fun. Thanks. Wrong answer on test 6. Oh, that's beautiful. Logic error. Let's go. Really? Why? I'm a little confused. Why would that be the answer? Hold on, let me think about this. Crap, I was probably going in the right direction before I just realized. Alright, let me just like copy this section here. And then we're just gonna undo a bunch of shit. No, I actually need to use undo history. Have you ever accidentally spilled like some kind of soda on your keyboard and now it's sticking? God, I hate that. We're missing a branch. Ah, here it is. I think this is the answer. Oh. What the fucking shit? No, wouldn't it be -1 though? I think. I don't know if that's gonna always be true, but I'm gonna try it and see what happens. Oh shit, I just realized. Fuck, I probably lost it now. God damn it. Alright, hold on. Buffio OS strings string convert. There we go. That ought to do the trick, I think. Really not sure. Wait, what? Oh, I see. Uh-oh. Why did that happen? Thought I fixed this already. What? Didn't I literally just have this working a moment ago? What in the world? Why is that happening? Let me think about this. Not really following what's going on here. Let's see here. It should be working. shit was that about? That was weird. Internet randomly just decided to crap out all of a sudden. Alright. What the heck is going on here, man? Why are we having so much problem with this? None of that makes sense. Let's see here. So the maximum is 0, which I find to be quite interesting. Oh, it's not getting set for some reason. Why is it not getting set? Oh, I know why. There we go. That seems like it'll work. Probably. Probably not. God, I hate edge cases so much. It'd be great if it would just, you know, work. Wrong answer on test 6. Interesting. So I'm missing some zeros, it seems. Huh. What in the world? Oh, wait a minute. Hold on, I might know the answer to this. I bet I know what the problem is, perhaps. Well, that quite ain't quite it, is it? One, two, three, four, 5 zeros. 1, 2, 3, 4. So that's the right amount of zeros with the wrong amount of things happening. What's going on here? So somehow, what? How are we? I might be understanding this now. -1 multiplied by divided by 2, I assume. I don't know if it needs to be rounded up or down, though. That's the only problem. Let's hope down. And this needs to be wrapped up. This actually, I don't think it does need to be wrapped, but whatever. Same answer as before. Let's see if that solves our little problem. I know it will solve that problem. What I don't know is whether or not it will solve all of the problems. Who would have thought that this particular problem would have been such a pain in the behind? Wrong answer on test 17. Oh, for the love of God. This is edge case hell. Fuck you. Ow, fuck, son of a bitch. I just hit my funny bone. Alright, so what's the issue here? So we have 3 1s. The output was 02. The answer was 3. Holy shit. What? Maybe I do need a roundup? Let me see if rounding up is the answer to this problem. So it's 2 right now. Let's see if... Why didn't it... Ah, that is not the answer. That is indeed not the answer. Let me think about this. So basically, whenever we're dealing with the numbers being the same, we go from dealing with a matrix to dealing with a number line. But in this case, well, no, that's not really true. I'm actually dealing with the matrix still. We're only dealing with a matrix in the circumstances that so let me think about this. If n is less than, I think, 4, we have an issue. If it is 4, then 4 times 4. Yeah, that would be rather 3 times 4, I guess. Kind of makes sense in a way. Wait, how many possible combinations are there in a circumstance where you can... It's a little bit more complicated than like a pen code type of math. I have no idea if that's correct at all, but you know. So basically we're saying if n is less than 4 and the number in question is the same, like the minimum and the maximum number are the same, then really shit, that's not even necessarily true. Oh my god. This is actually kind of complicated, I'm not gonna lie. So in the specific... God, this is so bad. This is literally... This is fucking... Edge case hell is what this is. This is edge case hell. I'm doing some kind of math wrong, I bet. Because it doesn't make sense to have to deal with this many edge cases, I think. There's got to be some kind of math I'm doing wrong. I just don't know what it is. I have no idea what kind of math I'm doing wrong. Maybe I am doing the math right. I don't know. Holy crap. Alright, well, we know rounding up is not the way. Surely there's no more edge cases. How could they even come up with another edge case? Like, what the hell else could they do? No, wait, this isn't an else if situation. This is an if situation. No, it is an else if situation. I could do that, but let's just do else if to be clean. Holy crap. Did I actually get all the edge cases? Let me think about this. I'm not confident I did, to be totally honest, at this point. I'm not confident in anything. This problem has been particularly difficult in a way I was not expecting at all. Like, not even a little bit. I'm not gonna lie. I was not expecting any of this extra code. I wasn't expecting to have to buffer. I wasn't expecting to have to do a bunch of edge case checking. But I'm trying to think about maybe if there's like some math I'm doing wrong, perhaps. How long has it been? I might check the tutorial to see if I'm doing this right. Ooh, it's been an hour and 30 minutes at least. Alright. As much as I really don't want to... No, wait. I'm going to give myself one more try. I don't think this will work. Because I'm pretty sure they're going to throw another edge case at me. I'm pretty sure the logic is wrong at this point. However, I'm going to try one more time. Because there's a chance that that was the last edge case. It might have been the last edge case. However, even if it was the last edge case, I still believe there's probably a much easier way to do it. And I want to look at the tutorial regardless. Okay, so I got another wrong edge case. I wonder what this one is. Let me just check it real quick. And I'm going to bust out the tutorial. Output 08. Answers 10. What? Why would it? What? What? Why would it be 10? Why would it be 10? What the heck? I mean, I know why it's 10. But if this is 10, then why was this that? Oh, lordy. Okay. Sorry, I'm just thinking about this. I'm trying to, like, do the math in my head, but the math is just not mathing, I've got to be honest. Man, I really don't want to look at the tutorial for this one. I really, really don't want to look at the tutorial. I really don't want to look at it. Hold on, let me just, give me a second. Let me at least try to think about this. Is there any equation that would work in all circumstances? Hold on. So oh lordy, why can't I think of this equation? Come on, think about this. How can I always get the correct maximum combinations? Should be simple. It's not going to be too complicated. There shouldn't be a lot of edge case checking with these. Try not to overthink it. So let me think about this. If they're the same number, then they're guaranteed to have the same amount of... They're guaranteed to have the same amount of... oh god, what's the word I'm looking for? They're guaranteed to have the same amount of numbers in the array. I know that much. So I still think I need to check to see if they're the same number, because I need to do some different math in that case. But the math that I'm doing in the case that they're the same number is probably not the correct math. So the trend that I've noticed is that we only seem to subtract one if the number is even. If it's odd, we didn't subtract one to get the answer. But I'm worried, so that would fix this one, that would solve this. That would also solve another thing. Wait, how do you do this again? I think it's and to 0. I think that's how you do that. Is it and? Is it the and symbol? Hold on. Yeah, I think it is. That tells me if it's even. But I need it to not be even. No, actually, I do need it to be even. If it's even, then we want max num to subtract 1 so that it's not even. Now I'm trying to think in my head why in the hell this would be the case. But this does satisfy, I think, all of the previous edge cases. But why is the question? Why does it need to be, why does the first one need to be uneven for the does this even work? It works on that. It doesn't even work on that. Wait, why doesn't it work on that actually? What's happening? Wait, 1, so 2 minus, that should have been even. So we're subtracting. Wait, what? Am I not doing it right? want to use modulus. I want to use bitwise. Oh, you're supposed to do 1, not 2. This would probably fix this situation, I assume. Yes. But the real question that I have is why? Why does that work? Why is that necessary at all? I'm not following that in the least. Let me think about it in a matrix. So let's go to my notes here. We're just going to think about this for a second. So let's say I have a matrix of 1s. And let's say I have 2 1s. There's only one combination that I can do for the 2 1s. So it looks something kind of like this, I guess. So 1, let's do space 1, and then 1, and then we have 1 here. Maybe in the circumstance that we have 2 1s, then we end up with 2, right? You following me? 3 1s, we have 3. Makes sense. If we have 2 and then 3, if we have 2 1s, then we have I mean, it's really simple, but the problem is so 2 times 2 is 4. 3 times 2 is 6. 2 times 3 is 6. 3 times 3 is 9. This is what my matrix looks like. How do I add a space again? That's right. Okay. So the graph makes sense. What doesn't make sense, of course, though, is why I couldn't program that. What is going on? Why is this not making sense to me in my brain? So in the multiplication table, anytime anything, it becomes itself, so then why? .5. Wait. I think the answer is coming to me. So if I would have done a float, would this have made sense? So that would have been 2.5 times 2.5, which is losing my mind. Dadgummit. Okay, calculator. 2.5 times 2.5. That's not right at all. God damn it. Fucking shit. Why does this work? I can't make sense of this. Holy crap. Why is this working? Why does it need to be... Which one is even needing to be even anyway? Actually, I don't even know if this will work. That's the funny thing about it. I'm just assuming at this point, but it just seems to satisfy all the other problems. So the maximum number needs to be uneven for this to work for some reason. And the minimum number, for some reason, has to be divided by 2? What? Oh, Lord, that don't make no sense. Alright. Let me just see if this works, because otherwise I'm just trying to make sense of nothing. I'm still trying to figure out. There's got to be... I really just don't want to look at the tutorial. I want to figure this out on my own, but I may have to. If this works, holy shit, how did that work? How did that work? Why did that work? What the fuck is this? What is happening? Why does one number need to be divided by 2 and the other number need to be uneven when they're the same? What the fuck? I have to admit, this problem has knocked me off my socks. I don't... I think the 1300s, when it comes to math problems like this, are starting to require some like higher level math than I actually know. I feel like somebody that like has been in college and taken a few college level math classes probably understands exactly why this is happening right here, but I do not. I cannot fathom for the life of me why we have to do this when the numbers are the same. I keep trying to think of it intuitively in my head and I just can't make sense of it. Why does it need to be uneven? Maybe it's a coincidence of some kind. Maybe it's some kind of coincidence. Maybe I'm dividing the first number or the minimum number wrong or something. Maybe I don't even need to divide it. Maybe there's something else I need to do. Wait a minute. Maybe it does make sense, actually, in a way. So if I have 5 ones and the way I'm currently getting this is I'm saying, all right, well, 5 is uneven. So we're doing 5. We're multiplying that by not 2.5, but 2, which equals 10. So maybe what I'm actually supposed to do, perhaps, is actually do and I guess this could also work in theory, like if I just did 4 times 2.5. If I'm not mistaken, that also equals 10, right? Yes. I keep trying to... Okay. So that also equals 10. So what I'm really doing here is I'm actually only bringing this down when this would otherwise be even. No, wait, that doesn't make sense. So when you divide an integer in Go, at least, and I assume in most programming languages, it actually rounds down. So what I would assume... No, that doesn't make sense. Or maybe it does, actually. So perhaps my original equation made sense. For example. But what we really need to do is do this. That ought to do the trick. Missing what? An argument list. What do you... What? What argument list? What are you... What are you talking about? What argument list? What is this thing talking about? What? Huh? Maybe that? What? Oh, right. That ought to do the trick. I bet some amount of money that this equation will work the same as what I just did. I think. Probably. Perhaps. I'm gonna try it. And if it does, if this works the same, then I might be able to generate at least a hypothesis as to why it works. No, we got a wrong answer already, so that wasn't right at all. I actually need this to round up. That might fix that problem, though I'm not entirely sure. What am I doing? I already got an accepted answer. I could just look at the correct answer. You know what? Let's look. Let's stop guessing and look at the fucking answer. Because we already got it. We got the damn thing. We just didn't. We don't understand it. So let's understand it. Let's just look at the tutorial and see if we can understand it. We already got the right answer. I don't know why I'm trying so hard. Unreachable code. There we go. Okay, let's take a look at the tutorial real quick. Okay. Four vertices of a square. Four vertices of a square with side length A. What? And sides parallel to coordinate axis are in this form. Two vertices are given. Calculate the two others and check the ranges. What? What? So it's talking about a square, which I guess makes sense in this case. Might have to look at some code. I hope it's code I can understand, because if it's C++, we might be fucked. I can't read C++. Source NA. What? Oh, you gotta be kidding me. Oh, wait a minute. We're looking at the wrong thing. I'm such an idiot. We're looking for in flowers, not the garden. Flowers. Okay, here we go. If all numbers are equal, then answer will be n times n minus 1 divided by 2. Oh shit, of course. What the fuck was I thinking? This is why I didn't want to look at the tutorial, because I knew I would feel like a dumbass. Dude, oh my god. Obviously, if the minimum and maximum values are the same, then the goddamn number is the same across the entire array. Which means you're only dealing with n. Fuck. So the actual solution was literally this. Man, I feel so stupid. Shit, fucking shit. Shit, fuck, shit, minus not minus, multiply by. I probably still wouldn't have I probably still wouldn't have got this, to be perfectly honest. But like, still, like I still don't understand what this math is right here. Like, I don't know why this is the case. But like, yeah. Alright. Int 64. See, that I already knew. So this was the only thing right here that I didn't understand the whole time. It didn't occur to me that I wasn't dealing with minimum or maximum values when they're the same. I'm only dealing with the total number of values at that point. The actual... Maybe I was too tired for this problem. But let me think about this. So why is it n times parentheses n minus 1 divided by 2? Let me think about that for a second. So it's still a matrix, obviously. Why minus 1, though? Divided by 2, I'm starting to understand, but why minus 1? Let me take a look at something. So what I think is actually occurring here, so what I believe to be occurring, is something kind of like this. So like, yeah, I think that's kind of what I mean. So what I'm thinking is, in the circumstance that the minimum maximum numbers are the same, then you actually run into an issue where you can't necessarily, like, so with, okay, so like, say you have 1 and 2. So say you have 1 and 2. You can also do 2 and 1. Right? So that's 2 things. But with 1, you can only do 1. Even though there's the same amount of values there. Right? You only do that once. The reason why is because swapping in these mean nothing. They're not new, if that makes sense. So in other words, what's happening here actually is that we're having a linear decrease in the amount of we're having a linear decrease in the amount, what the fuck? Why does that happen? Anyway, we're having a linear decrease in the amount of actual possibilities that can occur. Right? So that's what's happening there. What I don't know is why... So that's why we divide it by 2, at least. Because it's not a full... Like, the literal matrix is divided by 2. That's why the second number is divided by 2 instead of being a full number, because, well, we don't actually have a full matrix. So the question really remains, y minus 1. Right, of course, that should be obvious. It's in minus 1 because one of them is already being occupied. Right. So, ooh. How do I even explain that? So in the case that, like, oh boy. I don't know how to explain that on a graph, to be honest. All I know is it makes sense because you wouldn't want to include the minimum value as well, if that makes any sense. Oh god. Anyway, it's too late to be thinking this hard about stuff. I have completed another one. I feel like I kind of have some intuition about how the equation works. I am quickly going to test to make sure that this tutorial isn't lying to me, which I know it's not, but I'm going to do it anyway. And once this goes through, I think I'm going to go ahead and close out the stream and get some sleep. So that way, hopefully, I can have the brain power to do this tomorrow. And there it goes. That definitely was the solution. Well, I suppose that's it for tonight. Thank you for whoever was oh lordy. Thank you whoever was watching today. And all the VOD watchers, appreciate you as well. And this was a late night coding adventure. This was part 1. This particular stream is going to say part 1.1 because had some issues with Pipewire at the beginning. For some reason it was crashing, probably because I partially updated, which was a mistake. But anyway, we'll probably be doing this again soonish. I want to say probably tomorrow, if not tomorrow, some other time soon. I'm going to be doing a lot of these. I'm not sure when, but at some point we're probably going to be trying to learn some math together. We're going to take a break from codeforces and do some math. It does appear that I need a little bit of that, and I think in order to really be able to succeed in the higher levels of Codeforce, I'll probably need some better math understanding, to be honest. Or at least that's the general gist that I'm getting here. So at some point we'll be doing that. Probably not tomorrow. Probably just do more code tomorrow. But we'll see. Anyway, thank you all for watching, and hope it was as enjoyable as it could be. Yeah. Oh, I just realized that my preview wasn't live, so I was waiting for the... Alright, bye-bye.